Hi, I'm Hannah, and welcome to the a16z podcast. This episode of the podcast is all about enhancing what it means to be human, from what we eat, to what we measure, to what we produce, to how we perform. It is based on a conversation with Chris Dixon that took place at our inaugural summit event with Daniel Chao, CEO of Halo Neuroscience, Rob Rhinehart, CEO of Soylent, James Rogers, CEO of Apeel, and Geoffrey Woo, CEO of Nootrobox.
Hello. Okay, great. So maybe since you guys all do interesting stuff, maybe we should go down and just describe kind of what your product is and a little bit about it, what it does.
Yeah, sure. I'm happy to start. My name is Daniel Chao. I'm the founder and CEO of Halo Neuroscience. We're a human performance company, and specifically we build technologies that use electricity to stimulate the brain and produce temporary states of hyperlearning.
Cool. My name is Geoffrey Woo, and we started off in this hardcore biohacking community where people were tinkering with, Russian Alzheimer drugs, different powders. I had a sub-milligram drug scale, mixing different ratios of different powders and different compounds, and tens of thousands of people were doing this in their kitchens, in their home labs.
I'm Rob Rhinehart, co-founder and CEO of Soylent.
So I see a future where food is healthy by default. We started with a nutritionally complete powdered meal replacement. More recently released a line of beverages, flavored beverages, functional beverages, including caffeine and theanine. So there's an element of not just nutrition, but enhancement, a bar as well. We're also investing in research in the food system, in the food supply chain, with the end goal of reducing the resource costs of food production as far as possible.
My name is James Rogers. We're trying to improve the efficiency at which we're growing and producing food by reducing spoilage. And so our company does that by taking uneaten plant material, so things like stems, leaves, grape skins, orange peels, banana leaves, whatever's not being eaten. We blend those things up, and then from those blends, we extract very particular subsets of molecules. We turn those into a powder. We then dip fresh produce into that solution and allow it to dry. When it dries, it leaves behind this imperceptibly thin barrier of plant material on the outside of the produce, and that thin barrier slows down the rate that water evaporates out of the produce and slows down the rate that oxygen gets in. And by doing that, we can extend the useful shelf life of fresh produce by a factor of 3 to 5 times.
So James, can you frame a little bit the kind of state of food production?
If you look at all produce has the same characteristics. It's all seasonal and it's all perishable. The problem with that, though, is that regions of the world only have certain periods of the season when they can produce a certain kind of produce. And so now if you look at the regions of the world where labor costs are low, water costs are low, where we can produce high-quality fresh produce, and then you look at what the shelf life of that produce is, well, we know the speed of a boat, and you can start to draw rings around where produce is available during certain portions of the year. There's certain kinds of produce and certainly certain high-quality types of produce that we can't get year-round. And so it's trying to address is improving the transportability of that produce, but there's also some in-field applications as well that allow us to harvest at higher fruit maturity and quality.
Is this something that is a breakthrough in material science that couldn't have been done before, or why now?
It boils down to really what resource use intensity is going to become in the next 20 to 30 years. We're going to need 50% more food in the next 30 years to feed the world's growing population. It's going to need to come from improving the efficiency with which we're utilizing the food that we're actually growing. And if you look at food spoilage rates in the United States, they're around 40%. So we're throwing away almost half of what we're growing. And you look at all of the agricultural inputs that go into producing that food, 80% of our fresh water, 20% of our greenhouse gas emissions, all the human capital that goes into producing this food, all the pesticide usage that ultimately ends up in a runoff. And so why now is the problem is continuing to mount, and that it is enabled by new advancements in material science that we weren't able to do up until maybe 20 years ago. And that's really come to linking the properties of single molecules to the properties of a microstructure that can be developed with those molecules.
Yeah. So Rob, same question for you. Why now?
So I think a lot of advancements have been unlocked in both agriculture, food production, and food processing out of the eyes of the common consumer. It is staggering the amount of efficiencies that have been unlocked in both agriculture and food processing. The food processing technique that can ship a product that is maximally nutritious a neutral pH and store it at ambient temperatures. This took advancements in material science in terms of packaging, process engineering, in terms of filling liquid that is incredibly prone to spoilage. Honestly, a lot of people have become disillusioned with the products that the larger traditional food companies have been able to create. A lot of the big traditional CPGs of the world just became slow to innovate, risk averse, slow to adopt new technologies. E-commerce has been an enormous tool of ours, something that we were able to...
You're completely online right now, right? Like all of your sales are e-commerce.
We sell exclusively
So maybe
online.
if you can talk like a little about kind of the internet movements around your products.
Absolutely. We would not exist without what we've been able to do online. Launching with crowdfunding, building an online community, Reddit, our own forums. Having this degree of intimacy unlocked by the internet is just something that would not have been possible before. Bringing the consumer into our product development lifecycle, listening to them, asking them what they want, and then incorporating it into our products, releasing version numbers food, version 1.1, 1.2, 1.3, 2.0. It's something that would never have been possible before. Before you make a product, you hope people like it, you put it on shelves, you see if they buy it. We've been able to have this build, measure, learn, adopt, a cycle that never would have been possible before e-commerce and the internet. We can tolerate a higher degree of risk. We can take bigger chances. We can move faster with new technologies and techniques and test things online. If people like them, then we can push them through our national distribution channels. If something fizzles, then we can go back to the drawing board. So using the internet as well as recent food processing technologies have recently enabled us to make the kind of products we can at the price we can too. It's having this degree of sophistication in engineering and still ending up with a product that costs a few dollars is really fascinating. I mean, it's easy to make something expensive, but making something on spec by the millions at such a low cost that the typical American can afford takes a lot of technology and engineering.
So Jeff, maybe people don't know what Nootropics is. Can you talk about that and how it's a sort of internet movement? And,
Absolutely.
Yeah.
I think geographically, people that are looking to enhance themselves cognitively, physically, before the internet, right? You're basically constrained in our geographic proximity. Online communities really allowed people to connect from, people that wanted to live forever in Ohio could talk to people that wanted to live forever in San Francisco. So nootropics is this notion of cognitive enhancement. We have alcohol that push your cognitive state in a certain direction. You have marijuana that's pushing in a different direction. It stands to reason there are compounds in the universe that can push your mental state in a more positive, more productive state. The community is really drawn from, off-label use of different supplements, different research chemicals, and really just trading tips, trading, sort of hobbyist tactics. One thing I like to think about is if the homebrew computing club was a group of hobbyists, a bunch of tinkerers around computer parts in the 70s, 80s, I feel like that same kind of excitement, enthusiasm are the biohackers today, where people are tinkering with human inputs and tracking all these different biometrics. There's a fundamental desire for humans to want to enhance and improve themselves. I think that's one of the key factors that differentiates us humans from lower animals, being able to manipulate our environments and ourselves. Why I think it's particularly interesting today is that I'm a computer scientist by training, and one of my big theses on interesting applications are built on top of the available sensors out there. Right? If you look at mobile devices, a lot of the sensors have stagnated, but where sensors have really exploded in terms of availability and cost is sensors on the human body. So I think we can finally now start quantitatively tracking performance improvements on different things you can consume. So it's two sides of the same coin, right? Inputs, if you're not measuring your outputs, well, you're just sort of holistically guessing. And let's bring engineering, sort of first principle thinking to measuring humans, and then closing that loop to enhance ourselves.
And if you're not familiar with it, if you go to Reddit/r Nootropics, there's a whole community of people who develop what they call their stack, which is sort of their mix of different things, caffeine and all these other kinds of things. And then do a lot of these people will have various sensors on their bodies. Rob, you did that for a while too. So this is sort of a whole.
What model of CGM do you use?
Freestyle Libre.
I just got one of those.
Yeah, no, they're great.
They're great. So Daniel, can you tell us more about the technology and kind of what exactly you guys do?
Yeah, so we build a wearable neurostimulator. Actually, Sean, do you mind bringing that up? So this is a motor cortex-specific neurostimulator. So these, we call them primers, but that's a fancy word for electrode for us. This is where the electricity comes out of, and when you put this on, like a regular set of headphones, the neuroanatomy works out such that these primers, will cover the part of the brain, motor cortex, that controls movement in our bodies. So everything from skill acquisition to strength and explosion to endurance, all of these things can be sort of there's a neurologic component to all of those things. So how can we use neurostimulation in temporary states of hyperlearning, combine that with physical training to enhance athletic capabilities, really any sorts of movement? We've had neurosurgical teams reach out to us asking if they could use this technology to train the next generation neurosurgeons. We've had artists reach out to us to see if they could more gracefully move a brush over canvas. We've had musicians to help with the technical aspects of, say, playing a violin. So, sort of anything movement-based, we could accelerate the rate at which you learn.
Can you talk about sort of where you see your technology going and what you see as the future of food production?
Up until now, we have utilized what I'd say are chemicals. And the distinction in my mind between a chemical and a molecule is that a chemical is something that humans have created that hasn't existed before in nature, and that a molecule is something that nature reuses all the time. They're the kind of the fundamental building blocks of nature that get reused and recycled. And that up till now, we've been able to kind of deal with the negative externalities that are associated with crop production that result from these quote-unquote chemical and pesticide usage. But we're starting to bump up against those negative externalities actually impacting our lives and maybe not even becoming externalities anymore. They're getting internalized. And what we look at and say, well, nature's really done a hell of a job without us on this planet utilizing these molecules. And the way that nature does it is not by selecting a specific molecule to do one thing. The approach that nature has taken has been to use a microstructural approach. It's given, reptile scales. It's given plants a cuticular layer. And so the way we look at the future is to actually use those same building blocks from nature and basically use our knowledge of how to make those things, build the structures that we want, and build these microstructures that will give us crop protection. And right now we focus predominantly on post-harvest preservation of fresh produce because 40, 50, up to 80% in the developing world of produce just being lost. But that long term, we really have an opportunity to also start employing some of these strategies in field as not a pesticidal agent that's cytotoxic to some life form, but to use these molecules to form barriers that act as forms of molecular camouflage in the field and use this cloaking mechanism, which some organisms in nature already use. So we view the future as really an opportunity to use this knowledge of material science and knowledge of how to reconstruct nature's molecules into clever structures that will ultimately allow us to deliver produce that lasts twice as long for the consumer and is grown without pesticides.
Rob, the future of Soylent or future food?
I think you're going to see more technology, both in agriculture and in food products. Food production is still intrinsically inefficient, especially animal products. You just lose so much energy. You lose so many resources at every step, from the sun to grow the corn, to feed the animal, to process the meat, and of course, unconscionable amounts of fresh food gets thrown away. I think you'll see greater adoption of preservation technologies that aren't in mass adoption today, such as irradiation. I think you're going to see more genetic modification, not less. We're not going to be genetically engineering soy and corn anymore. It's much too slow. It's much too inefficient. We're going to grow more basic organisms, basically the most basic plant, which is algae. Algae has been eaten for centuries. Seaweed, if you like sushi, spirulina is a well-known superfood. And we're going to see more adoption of single-celled organisms. Yeast has, of course, been part of the food system for a very, very long time. But just recently have we gotten the tools to engineer these organisms. So I think we're going to use single-celled organisms to produce the same proteins and fats and carbohydrates that we used to wait an entire growing season for, that we can have organisms that double within hours. And I think we can use the front-end techniques. We can use texture modifiers, synthetic flavors to make meats that are much more convincing and much more sustainable and efficient to produce. I think that a lot of food is going to be grown in giant steel vats rather than fields, but that means that we're never going to run out of arable land because all you really need to make food is sunlight and air and water. So if you lose less energy at every step, you're going to produce food a lot more efficiently. You're going to be able to feed people a lot more people with a lot more nutritious food. More food will be more nutritious, the cost will lower, and absolutely the resource costs and the sustainability factors going to become much more important.
All right, so we have a question over here.
This question is directed toward Daniel and Geoffrey. Both of you have different mechanisms for putting your brains in different states. The obvious question is there any synergy here? What happens if you combine these two things? Can you speculate on what would happen when you put them together instead of using them separately?
So there's a really interesting paper that came out about 2 years ago that looked at the treatment of major depression. And it's a 2x2 factorial design, 120 subjects, 30 in one of 4 groups. You either got electrical stimulation alone, or you got Zoloft alone, you got the two combined, or none at all. Electrical stimulation and Zoloft did about the same. So that's awesome because you can use electrical stimulation as a potential replacement for a drug. But the two did better yet together. So, it suggests that there's some sort of potential, there's some sort of feed forward, right? Some sort of potentiation that goes both ways.
Yeah, cognition is such a complicated notion, right? You can break that cognition to certain measurable psychometrics like reaction time, working memory capacity, et cetera. And there's so many different pathways that, attack each of these and outputs. Part of the notion of stacking different compounds or different devices is, figuring out synergies. I think that's like a ripe area of research because most studies are focused on single compounds. It's simpler, but I think in the future there will be just systems, perhaps something that's like automating a bunch of different variables being inputted to find optimal outputs for certain conditions.
If I could just add, one of the challenges here, right? I mean, both Jeff and Rob, you're doing a lot of, you're commissioning a bunch of scientific studies, because one of the challenges here, there just haven't been that much research on a lot of these things.
Yeah, we've run a peer-reviewed study. It'll be published later this year in a Nature journal using a controlled study, studying the effects of tolerability of people living on Soylent and measuring a lot of biomarkers, vitamin, mineral, nutrition, and otherwise, and mental cognition is a big one. But I would just point out that nootropics have been a part of our society for a very long time. I mean, how many people in this room have caffeine in their system right now? Why not theanine? Why won't theanine be as or even more adopted than caffeine or new novel nootropics that have yet to be discovered? And what if those end up in our breakfast by default? What if those end up in a lot of our food products by default? I think that the line between food and medicine and enhancement may begin to blur.
Yeah, I see it as just inputs into the human system, right? If you just, again, boil down humans, I mean, obviously we're more complicated than a computer, but it's a system nonetheless, right? A set of inputs coming in for some predictable type of output. And foods, supplements, consumables, different regimens, wearing a Neuro stimulator, all different inputs into the human system.
All right, great.
So all really fantastic and inspiring concepts. And my question would be to you two gentlemen, how do you think about scalability and extending these ideas beyond the already sort of bought-in sustainability community, or however you might define the niches that would be more receptive immediately to the concepts that you're bringing to market?
Yeah, I mean, the way that we think about it is that we don't really want to market our products. We want to market the benefits that growers receive by using our products. So one little anecdote I'll just tell is that most of you probably have had the complaint, my tomatoes don't taste like anything anymore. They taste like water. And the reason for that is that the tomatoes harvested at a stage 3, at a color index of 3, which means it's green. And you really want to consume it at a color index of 5 or 6 when it's that deep red. And the reason for that is that the fruit will continue to ripen on the vine. But if you pick it early, you'll end up with something that has only 1/5 of the nutrient density that it would is if you let it mature all the way to that state of 5. But for transportability reasons, you will choose to harvest at a 3, let it mature during transit, and just sell that tomato that still looks like a great tomato, but it's only got 1/5 of the nutrient density. And so rather than us talk about how great our technology is to consumers, we work with our partners, with our growers, to say, here's some new things that you could do with your harvest practices to improve the quality of fresh produce that you're harvesting and delivering to your customers, so that you're able to advertise a more nutritious, better tasting tomato to the end consumer. We think that's something that's general interest and not just to a niche audience.
I think that's a really good question. Part of it boils down to how do you get people to care about sustainability? As a company that we do sell directly to consumers, asking someone to pay more for a more sustainable product is a long shot. Most of the market is probably not going to be up for that. I think you have to confer some benefit directly to the consumer. But I think that's entirely possible because if something is more sustainable, then the resource costs are lower and you have more control over its design. So I think you need to combine the sustainability factor with things that confer a consumer benefit, such as lowering the cost or putting more work into the design and making it a more attractive product.
All right, we're out of time, but thanks, everyone.
Thank you.